Welcome to Study Loop.
Okay, so in this problem, we have two batteries, and then we have a big wire that's going from the uh, making two junction points over here and here. Now, if we apply Kirchhoff's law on the right side of the junction, we see that I1 and I2 are going towards the junction, and then I, or the total I, is coming out. So if we try to solve for the junction rule, it's going to give us I equals I1 plus I2. That's why we wrote I1 plus I2 here. Now, these are the given parameters that we have. We have internal resistance, we have the resistor that's attached, then we have two different EMFs of the batteries. Now, for the loop rule, we're taking two loops. One is with the internal wire, which is connected to this big wire, and then for the second loop, we are taking the outer wiring. So for the first part, and for both of the loops, we're choosing a direction which is counterclockwise. Now, for the loop with green arrow, it's going to be epsilon 1 or EMF, which is positive, and then it's going to be minus I1 times R, because I1 and the direction are in the same direction, so that's why there's a voltage drop. And then we have I1 plus I2 times big R, and again there's a negative sign because there's a voltage drop. And for the black arrow, or the outer loop, we'll have epsilon 2 minus I2 times R, again because they're in the same direction, we have a negative sign. Then it will be minus I1 plus I2 times R, and they're all equal to 0. So now we have three equations and so now we have two equations and two unknowns, because we have already solved I, which is I1 plus I2. So yeah, if we try to solve for it, what we have is, so what we're doing is, first we're writing this equation in terms of I2, and we plug in the values there, and then what we get is an expression in terms of I1, right? And we can use this expression and put this over here in place of I2, so that we can solve for I1. And that's what we did here. So in place of I2, we plugged in this value, and let's see. Let me see if I did anything wrong there. No, I think we're fine. Yeah. Right. So if we do that and solve for I, we get a current as this, which is 1 point, which is minus 1.129 amps. And then we can plug this back here to solve for I2, and that gives us 1.728 amps. So now we know the currents. So what we can do from here is, so we need the voltage across big R. So to do so, it's just going to be I1 plus I2 times R, because that gives us the voltage drop. So yeah, that's going to be this. And since we know the values, so we can directly plug in the numbers and solve for it. It's going to be 4 ohms, and then for I1 we have negative 1.129 amps, and for I2 we have 1.728 amps. And we solve it, and get our voltage drop as 2.396 volts. Thank you.